Hi, everybody. Welcome back. We just talked about why we should ventilate our buildings. Now let's talk about how. We'll start out by touching on the code requirements and then go into the different ventilation systems. Let's move on to some code requirements. Every occupied space shall be provided with ventilation according to the International Mechanical Code. That can be natural ventilation or mechanical. So for commercial buildings, they have very complex code requirements. You'll find the natural ventilation system requirements in section 402 of the IMC and the mechanical ventilation system requirements in section 403. Also, just note it's not required to provide mechanical ventilation when you're not providing heating or cooling. For residential, mechanical ventilation is required for any dwelling units, which means homes, all right, with less than 5 air changes per hour. All right, and that's most new homes. The old drafty homes might have had an air change per hour of 4 to 5, all right, but our newer homes are much tighter than that. And so in general, mechanical ventilation is required. Also check your local codes. I'm here in California, and California does not have this 5 air changes per hour rule. It simply says that all homes shall have mechanical ventilation systems. All right, so you know you need to provide a ventilation system. What kind could you provide? Well, these whole building ventilation strategies can be divided into 3 types, and they are exhaust only, supply only, and balanced. The exhaust only is the simplest to install, the least expensive, not most expensive, the least expensive, but it is inefficient because it takes your beautifully conditioned air that's been heated or cooled and you've spent energy on it and throws it away, exhausts it. All right. A supply only system is the positive side of it is that there is positive pressure and no infiltration. So pollutants from outside don't get in. But the downside is that you are constantly bringing in air from outside and you bring in the heat and the moisture that comes with it. So we've come to the balanced system, which balances an equal supply and return. The advantage of this system is that you can use an HRV or an ERV equipment to recover up to 80% of the energy in your air exchange. So it's got a high efficiency. The downside is that it's a more complicated design and therefore has a higher initial cost. Let's take a look at a diagram of these 3 types. Starting with the exhaust only on the left-hand side, you can see here is our interior space right here. And all we're doing, we've got a fan and we're pulling air out of the space and blowing it or exhausting it out the roof. How is air coming in? How are we getting some supply air? It's either coming in through a direct register, or this little squiggly line is supposed to mean infiltration. All right, so that's how we're getting air in here. And your space in the room is going to be under negative pressure. Moving on to the supply ventilation, surprising it looks almost the same. Only check out the arrows. This time we're drawing air in from the outside and blowing it into our space. Right? And then how does it get out of the house? Well, it can either get out through a direct vent or through exfiltration, where it trickles out through all the tiny leaks and cracks. Your space in the house here is under positive air pressure. Right? By the way, I think these interior lines are supposed to be a wall with a door, and we're seeing that the air is sneaking under the door. let's move on to the balanced ventilation system. All right. In this case, we have a supply system down here, getting fresh air from this inlet and then blowing it into your room with your supply registers. Then you have a separate exhaust system that is taking the return air, or the exhaust air, sorry, not return, and pulling it out of the building. Oh, wait a second, Sarah, why isn't there any return air? It turns out we're only looking at ventilation systems in these diagrams and not heating and cooling systems. But most homes will combine all of these systems into one system. So let's take a look at what that could look like. And here's one right here. So let's take a look. This is a balanced system also using an HRV, heat recovery ventilator, all right, which is a tool right here. So let's start with our supply. The outside air is going to come in. It's going to go through the HRV and gain some heat by passing over and around that inside air that's being exhausted. But let's follow the outside air coming in. Here's a damper that can control how much outside air you want to enter your system. And then it comes in right here and will go into your air handler, be heated through your furnace, and then into the supply of your spaces. All right. Now let's watch the return air. Return air would come in. All right. Some of it gets exhausted to the outside. As it passes through that HRV, it's going to transfer all that nice heat or cool, all right, to the outside air that's coming through and then be exhausted out that way. And the rest of it is going to return, okay, and be recirculated through that furnace, through that heating system, and thus again into the supply air of your house. All right, everybody, in this video we just covered ventilation, what is it, why we need it, and different types of ventilation systems. Thank you.